We are at gotomath.com, and go to math. Just thinking my microphone wasn't working. Anyway, we're doing related rates. Calculus, obviously. I don't know, maybe it's not obvious. We're in this section right here. We're going to be looking at the this particular problem here. However, the numbers are going to be different. Okay, and actually, this is it right here. We're going to find the area of a rectangle. Well, wait a minute. The area of a rectangle is increasing with respect to time. And it says find dA over dt when W is 10 centimeters, L is 2 centimeters, dW over dt is 8 centimeters per second, and dL over dt is 6 centimeters per second. Alright, so this is not going to be too bad. Let's move over here and I don't know, maybe I'll try drawing a rectangle here. We'll cheat. We're going to cheat. So there's a rectangle with a nice big bold perimeter there, outline. Anyway, and you know what? It's not to scale, so don't worry about that. Okay, I just noticed that. Uh, okay, this thing is not to scale. Well, I guess we could do this. This will be L, and this will be W. How's that? Normally this is L and that's W, but it doesn't matter. Okay. All right. We're asked to find dA over dt. All right. So we need to know what the formula is for finding the area of a rectangle, and that's actually pretty easy, right? Area is equal to length times width. Length times width. All right. Now let's just go over here and write down everything that they gave us. They gave us W is 10 centimeters, right? L is 2 centimeters. dW over dt is equal to 8 centimeters per second, and dL over dt is equal to 6 centimeters per second. Alright, so, well, it's kind of to scale, but not really. Alright, anyway, so W is growing. This distance is growing a little faster than this distance, okay? But the thing is getting larger with respect to time. And we want to know what dA over dt is when these guys here are met, okay? So this thing was probably a little bitty rectangle, and then it just started growing, growing, growing. All right. So if we want dA over dt, we're going to need to take the derivative of this guy with respect to t. All right. So the derivative of a is 1, but then we're going to write dA over dt, and we're going to use the product rule here to this. The derivative of L is 1, but I'm not going to write that, and we just write dL over dt times W, can't forget that, plus, and then rewrite L, and the derivative of W is 1, but then I'm not going to write that, but I have to write dW over dt. Okay, we got plenty of those practice problems in earlier sections. Right. And so now all we have to do is just simply plug our numbers in. I mean, that's that simple in this problem. So we have 6 times W is 10 plus, and then L is 2, and then dW over dt is 8. Okay, so we end up with, what do we end up with? I'm trying to remember. I don't know, this is 60. You're going to really make me do this. 16, 76. Is that right? I feel feel like that's a small number for some reason. I don't know why. 76. Now it said rounded 2 decimal places, so we're going to throw 2 zeros on this thing. Now remember, our units would be centimeters squared per second. Centimeters squared per second. Of course, I'll rewrite dA over dt here. Okay. So we had 6 times 10 is 60, 2 times 8 is 16, 60, 76 centimeters per second. Let's bring this up. Click that. Scroll down. Okay, yeah. So there it is. Alright. So remember where you are. You are at related rates. We're in this section right here. Okay, so you want to see that problem come up, just click on. Did I say that section or that section? I've already forgotten what let's see. Yeah. Okay, there it is, this section here. I forgot what section I'm at. Anyway, we're go to math.com, so come on over, let's work some problems. Alright, see you there, bye.